So imagine you're putting like, I don't know, 80 hours into a massive fantasy role-playing game.
Right. Oh, yeah. We've all been there.
Exactly. And early on, maybe around hour 10, you make this careless mistake and accidentally set fire to a small grove of trees near some village.
That's a total accident.
Right, and you move on. You completely forget about it. But then, in hour 80, you go back to that same village,
Okay.
and a local merchant actually recognizes you. He refuses to sell you a crucial healing potion, and he specifically brings up the fire you started weeks ago in real time.
Which is wild.
It is, because no game developer anticipated you doing that, you know? There's no pre-written script telling that merchant to hold that specific grudge.
The character just remembers.
Exactly. The character remembers, and the world has actually adapted to your choices. And today we're diving into the exact technology that is making this scenario possible.
Which, I mean, let's be real, is a massive departure from how digital worlds operate right now.
Oh, totally.
For a long time, the holy grail of gaming has been these dynamic living environments. But historically, if a game experimented with putting generative AI inside a character,
Like a smart NPC.
right, that character might be able to hold a decent conversation, sure, but they acted like they had severe amnesia.
Yeah, literally resetting their brain every 5 minutes.
Exactly. But now we are talking about game environments and inhabitants that actually carry a bias based on your shared history with them. They evolve organically.
And the technology claiming to finally fix this amnesia problem is called collapse-aware AI, or CAAI.
CAA, right.
So to figure out how this actually works, I've been going through this really fascinating stack of material for our deep dive today.
It's a pretty dense stack, too.
It really is.
Yeah.
There is a highly technical academic record from Zenodo version 2.1.
Authored by Marcos Varel Moss-Ross.
Yeah. He publishes under the initials MR. We also have an internal architecture overview of CAI, plus a Substack post MR wrote on the philosophy of emergent gaming.
And the GitHub repo.
Right. Finally, this public GitHub proof pack that kind of serves as the official origin record for the project.
So before we look at how this new system actually fixes the problem, I think we have to talk about why current generative AI tools fail so spectacularly in games.
It's a great point.
Because the architecture document you mentioned, it actually diagnoses the core issue. It says current game AI stacks treat behavior as a, quote, one-step generation problem.
Meaning the system is just instructed to generate a response, hand it to the player, and then instantly forget it ever happened.
Right. It takes your immediate prompt, spits out a localized reaction, and just dumps the data. The loop completely closes.
Because it's not designed to carry any weight forward.
Exactly. And because it's not carrying the weight of past interactions, you get this unpredictable behavioral drift.
Where a character might be your sworn enemy in one breath.
And then a cheerful tour guide in the next.
Yeah.
Just because your new prompt lacked the context of the previous one.
Yeah, MR brings up a really interesting contrast in the Substack post to highlight this. He points to Logitech's intelligent gaming agent.
Oh, right. The overlay.
Right, and Logitech's tool is incredibly useful for what it does, but it sits completely on top of the game.
Yeah, it's an external assistant.
Exactly. It's meant to help streamers manage their Twitch chats or run polls or maybe help devs generate art assets faster. It's totally additive.
It's built for external management and production speed. It's not for internal world building.
Right.
That approach treats AI as just a utility rather than an actual engine of the game itself.
It essentially functions like a sassy chatbot overlay.
That's a good way to put it.
I mean, if you try to force that kind of front-end assistant technology into a video game character, you're basically talking to someone who resets their entire brain every time they blink.
Exactly. So building AI over the game just doesn't work for creating deep, persistent memory.
Right.
Which is why the architecture overview emphasizes that CAI is intentionally designed as a background engine.
It doesn't sit on top of the game at all.
No, it is buried deep underneath it. It acts as a middleware layer.
And this is where I think the engineering gets really clever. Because the Phase 1 gold build middleware architecture, which is outlined in that Zenodo record, it separates the actual generation of intelligence from the governance of behavior.
Let's break down what that separation actually means functionally.
Yeah, because from reading the sources, it seems like one of the biggest hurdles for game devs is that building a brand new, perfectly consistent AI model from scratch is just prohibitively expensive.
Oh, it costs a fortune.
Right. Or, alternatively, trying to make an existing model remember everything by just constantly stuffing thousands of pages of a player's history into the context window.
That makes the game run terribly.
Yeah, the performance just tanks.
Because expanding the context window indefinitely is just computationally unsustainable for a massive game. It slows everything down to a crawl.
So CAAI just bypasses both of those dead ends entirely.
Right, it doesn't retrain the underlying base model. And it doesn't rely on infinite context windows either.
Instead, it places this highly rigid control structure between the game and whatever creative AI model is generating the ideas.
And the documentation maps out a few specific layers to actually make this happen.
Right, so you start with the game or app layer. That's your standard user interface, the visual scene, the button inputs you make as a player.
Standard stuff.
But then, to prevent this new AI engine from just completely breaking the game's existing code, they use something called a Flask API and an adapter.
Right.
Now, I know API stands for Application Programming Interface, but in the context of this game engine, what is that layer actually doing?
You can think of the Flask API and the adapter as basically a universal translator.
Okay.
The documentation refers to this as keeping the outer contract stable.
Outer contract stable, right?
Because game developers write millions of lines of code governing physics, lighting, user menus, all of that. If the underlying AI engine updates or changes how it formats its data, it could instantly crash the entire game.
Because the game wouldn't know how to read the new format.
Exactly. The API layer ensures that no matter what kind of chaotic thinking is happening down in the AI core, the data passed back up to the game always arrives in the exact predictable format the game engine expects.
So the devs don't have to rewrite their entire game every time the AI gets an update. That makes a ton of sense.
It saves a massive amount of work.
So once we get past that translator layer, we hit the actual brain of the operation, which is the crown selector.
The decision core.
Yeah, the overview calls it a sealed black box decision core. It basically takes all the candidate behaviors that the base AI model dreams up and scores them.
Right.
And sitting right next to it is the governor layer.
Which is the ultimate stability control. Because, generative AI models are notorious for hallucinating.
Oh, totally. Inventing facts that aren't true.
Right, or taking actions that just completely break the logic of the game world. So the governor actively blocks those unstable paths.
It's acting like a filter.
Yeah, it evaluates the outputs from the crown selector and stops any unpredictable drift before it ever reaches the player's screen.
It actually sounds a bit like a publishing house.
How do you mean?
Like, if the base generative AI model is this wildly creative but totally erratic writer who just throws out 10 different conflicting ideas for a scene at once,
Okay, I see where you go.
then the crown selector and the governor are acting as the strict managing editors. The crown looks at all 10 ideas and picks the one that makes the most narrative sense.
Right.
And then the governor makes sure that idea doesn't violate any established facts or formatting rules before it gets quote-unquote published to the game.
That is the exact dynamic the architecture creates.
Wow.
And because the crown acts as that editorial filter behind the scenes, a developer can completely swap out the underlying creative engine.
Wait, really?
Yeah, meaning they could upgrade to a newer, smarter base AI model years down the line without altering the crown's editorial standards or breaking the game's UI.
Which is absolutely critical for a game that's meant to be played for years.
Exactly.
But I want to zero in on the quote-unquote editor for a second, the crown selector. How does a piece of software actually decide which narrative idea is the best fit?
Right, the selection process.
Because the internal notes refer to this decision process as collapse, and it's apparently driven by something called Varel's law.
Yeah, so Varel's law is essentially the philosophical and mathematical foundation of CAAI.
Okay.
It argues that the perception of time, memory, and emergent behavior in a digital space arises entirely from memory-weighted informational collapse.
Meaning the system takes this massive cloud of possibilities and just collapses it down into a single action, weighted by what happened in the past.
You got it.
And to actually calculate that weight, the crown selector uses 3 canonical behavioral signals. The first is recency, which is pretty straightforward, what just happened in the game a few seconds ago.
Makes sense.
The second is salience, which the text describes as whatever carries the most emotional weight or gameplay importance.
Yes.
And the third is anchors, which are these stable underlying reference points that preserve a character's long-term identity.
And the architecture overview actually gives us the mathematical sketch for this whole selection process.
Right, there's an equation.
Yeah, it calculates a score for any candidate action. by taking those three signals, recency, salience, and anchor alignment,
Okay.
and it multiplies each of them by their own specific weight.
So if an NPC is inherently cowardly, their anchor score for running away from a fight will always be really high.
Exactly.
But if the recency score shows the player just handed them a legendary shield, and the salience score recognizes the emotional weight of feeling protected.
Those numbers might outcompete the cowardly anchor.
Right. And then the NPC actually decides to stand their ground.
Exactly. And then the formula factors in the final two elements.
Okay, what are those?
It adds the governor's mathematical contribution, which basically rewards stability, and then it subtracts specific penalties for any action that represents a bad fit or erratic behavior.
So the highest resulting number is the action that quote-unquote collapses into reality.
Right.
The documentation mentions this system has two operating modes. There's bias enabled, which uses all this complex math to create behavioral continuity.
Right.
But there's also bias disabled, which just runs on a deterministic baseline.
Which is mostly for testing.
Yeah, it seems like that exists purely so devs can turn the memory off and compare the two states just to make sure that AI is actually working.
Exactly.
But looking at the variables in that equation, I mean, it mathematically weighs emotional gain and it assigns numerical values to a character's identity.
Right.
Are the creators of CAAI claiming they have programmed actual sentience or consciousness here?
Oh, not at all. The Zenodo record goes way out of its way to shut down any claims of sentience.
Okay, good to know.
Yeah, MR explicitly states that the math provided is just a public safe point to express logic.
A public safe point.
Right. He explicitly warns developers against using what he calls overclaimy sentient marketing.
But then when the documentation talks about emotional game, what is the system actually measuring if it's not, feeling anything?
It is detecting affect proxy markers.
Affects proxy markers.
Yes. So when a player types a sentence or takes an action, the system analyzes the text or the gameplay state for tone shifts, contradictions, or urgency.
Okay.
It's recognizing patterns that represent hostility, kindness, or fear,
Right.
and adjusting the mathematical weights accordingly. It is a highly calculated behavioral bias. It is not a genuine emotion.
Okay, so a character isn't actually angry at me. My actions just triggered a high salience penalty for hostility, which limits the responses they're allowed to give.
Exactly.
Now, that phase one mathematical equation makes perfect sense for a localized interaction, like talking to a single merchant in a small room. But how does this scale up to an entire game? Because a modern open world game has thousands of characters and millions of past interactions.
How are you?
Storing an entire constantly updating web of memories for every single NPC sounds like it would just completely fry a console's processor.
And that scale issue is exactly where the Phase 2 framework comes into play.
Okay.
Because you can't just run that simple equation for millions of entities simultaneously. Phase 2 moves from basic mathematical scoring to advanced probabilistic modeling.
Through the connectivity topology layer, right, the CTO.
Yes, the CTO.
The Zenodo source describes the CTO as a stimulus-conditioned weighted graph.
Which sounds intimidating, but it's really elegant.
Yeah, so the nodes in this graph are the distinct memories or the anchor traits of the characters, and the edges connecting those nodes represent associative links.
Right.
So the system maps out how recently two separate concepts were activated together.
And to manage that massive processor load you mentioned earlier, the CTL dictates that the game isn't actively thinking about every memory at once.
It's not.
No. It only evaluates memories that are relevant to the immediate stimulus. And to do this, the selection relies on Bayesian posterior weighting.
Okay, Bayesian probability usually trips people up. I mean, it definitely trips me up.
It is dense, for sure.
If I am reading this correctly, it's basically a way of updating a belief based on new evidence.
Exactly.
The formula they provide states that the posterior probability, which is the final adjusted belief, is proportional to the prior belief multiplied by the likelihood of the new evidence given the current state, stimulus, and topology.
Right.
In plain English, how does this actually function inside the game world without melting the hardware?
Imagine the connectivity topology layer as a massive detective's string board covering a wall.
Okay, I can picture that.
Every pin on the board is a memory, and the strings connecting them are the associative links. When a player is just walking around an empty field, the board is dark. The processor is resting.
But the moment the player does something...
The moment you interact with a character or an object, that action acts as a stimulus. It plucks a specific string on the board.
Oh, wow.
The vibration travels along the associated links, and only the connected pins light up.
Right.
The Bayesian weighting is just the math used to calculate exactly how brightly those specific pins should glow based on the new evidence of what the player just did.
So the game only spends processing power calculating the nodes that are vibrating. It completely ignores the thousands of pins that remain dark.
Precisely.
So if I equip a specific weapon I haven't used in like 60 hours of gameplay, the system doesn't search a massive database of my entire history.
No, it doesn't need to.
It just plucks the weapon string, which vibrates along the associative edge to a specific battle memory node from 60 hours ago. And suddenly an NPC reacts with fear.
Yes.
The whole web doesn't have to be processed, just the ripple.
Which is what makes it computationally viable for massive environments.
Yes.
The system isn't memorizing a script. It is continually updating the probability that a past event is relevant to the current moment.
That is incredible. Okay, so we've covered the heavy technical architecture. We talked about the Flask APIs bridging the code, the crown selector filtering the ideas, and the Bayesian math running the memory web.
Right.
But the ultimate question for anyone actually picking up a controller is, what does playing a game powered by this actually feel like?
Well, the GitHub repository gives some insight into how developers are meant to use this.
Yeah.
Interestingly, it is purely a quote-unquote public proof pack.
Oh, really?
Yeah, you won't find any runnable proprietary code in the repository.
It seems heavily guarded. It just contains the origin statements, the white papers, and the architectural documentation.
Right, because the proprietary code itself is governed by what they call the Virl Solace Sovereignty Protocol.
Okay.
They are basically positioning this technology as licensable middleware. They're offering it as a plugin for major development engines like Unity and Unreal.
Got it.
So they're targeting AAA studios and indie devs who want to integrate this underlying memory architecture, but who don't want to have to build it all themselves.
And the end goal of integrating this plugin, at least according to the Substack post, is emergent storytelling.
Yes.
Because game narrative are usually built on these massive branching scripts. If you choose option A, the game loads scene A. If you choose option B, it loads scene B.
It's very rigid.
Yeah. But with CAAI, the narrative isn't pre-written. It emerges organically from that vibrating field of memory and bias.
And an MR uses a really great core example in the Substack to illustrate this, which actually touches on the scenario we discussed at the very beginning of the deep dive.
The forest fire.
Exactly. Imagine a player burns down a forest in the game. In a traditional game, devs have to hard code the consequences of that.
Right.
The forest either stays as a burned out texture forever, or it slowly respawns over time using a basic random number generator algorithm.
Meaning the trees just pop back into existence identically to how they were before, as if nothing ever happened.
Right. But with CAI integrated into the environment, the regrowth isn't randomly generated or scripted. The environment itself carries the quote-unquote echoes of that past event through the topology layer.
So the game world actually remembers.
Yes. The new trees might grow back differently based on the severity of the fire. The wildlife might migrate in entirely different patterns.
And crucially, the NPCs returning to that area will carry memory echoes.
Exactly.
They will remember the fire, and they'll remember your role in it, without the game needing to consult some massive, rigid database checking a box that says, player burn forest equals true.
Right.
Their future choices, the prices they charge you, the dialogue they offer, it's all mathematically biased by the Bayesian weight of that memory.
It creates a reality where actions have systemic, lasting consequences that echo through the world long after you've moved on.
That's fascinating.
And you don't get a flashing UI notification that says, this character will remember that.
Right. No immersion breaking.
Exactly. The world simply reacts with a deeper, almost eerie logic.
It completely flips the traditional dynamic of a video game. As MR points out, the AI in these systems isn't just a tool designed to help us play the game or to serve as a punching bag for our actions.
No.
This technology actually allows the game to play us back. It reacts to us, it holds grudges against us, and it adapts its behavior based on a deeply held, mathematically structured history.
It really demands a complete reevaluation of what a save file actually is.
How do you mean?
Well, historically, a save file is just a static record. It holds a list of your inventory items, your current level, and your coordinates on a map.
Yeah, standard data.
Under the CAAI architecture, a save file becomes a living, interconnected web of biases, simulated traumas, and nuanced relationships that actively shapes every future interaction you have.
So collapse-aware AI represents a fundamental ground-up shift in digital architecture.
Oh, absolutely.
We are moving away from treating AI as this superficial chatbot overlay that forgets who you are every 5 minutes. Instead, the industry is moving toward a hidden middleware layer, a background engine that uses Varel's law, governor constraints, and Bayesian topology to create persistent, evolving worlds that remember.
And the technical execution is brilliant, precisely because it doesn't try to replicate human consciousness.
Right.
It relies entirely on the cold, efficient math of probability and weighted variables to simulate that continuity.
But that does leave a lingering question for you to think about. If an AI middleware like this can perfectly simulate a character's long-term memory, their emotional anchors, and their grudges using nothing but stimulus-conditioned math,
It makes you wonder.
it really does. At what point does a video game character's simulated trauma start to feel entirely real to the person holding the controller? If you know the digital world truly remembers everything you do to it, and that those echoes will never simply reset, how will that change the way you choose to behave the next time you log in?